Hello viewers, Kinematics question 7. The 18L36R runway at Hamilton Airport is 2,059 metres long. Part A. Determine the minimum acceleration of Boeing 757, which requires a speed of 260 km per hour to take off, must undergo on this runway for a successful takeoff. So the first thing we need to find here is we need to convert 260 kilometres per hour into metres per second. So 260 kilometres per hour is 260,000 metres in 3,600 seconds. And if we calculate that, we get 72.22 metres per second, which must be the final speed on the runway. If the acceleration is the minimum, it must be travelling at 72.22 metres per second after a displacement of 2,059 metres. And we also know that the initial speed must be 0. We're trying to find the acceleration, and our four variables here are v, u, a and s. Therefore we need to use v squared equals u squared plus 2as. Here u is 0, so that becomes v squared equals 2as, and we're solving that for the acceleration, which is going to be, if we divide through by 2s, we get a equals v squared over 2s, and if we calculate that, we get 72.22 squared divided by 2 times 2,059, and that gives us an answer of 1.27 metres per second squared. So that's the minimum acceleration that the Boeing 757 must have on the runway. Okay, question B. Find the distance the plane travels in the second of acceleration. Okay, so there's a little bit of wordplay going on here, but let's imagine that that's the point where the plane starts. Let's say it's here after 1 second, and let's say it's here after 2 seconds. So this is the distance that it goes in the first second. So this will be s of 1, which tells us the distance after 1 second, and that'll be s of 2. So that is the distance it travels in the first second, and this will be the distance it travels in the second. So that's going to be, we want s of 2, which is the distance that it has travelled in total after 2 seconds, minus what it had travelled before the beginning of the second. In other words, minus what it had travelled after 1 second. Now we know that u is equal to 0 here. We've found the acceleration to be 1.27 metres per second squared, and the time is known because that's either 1 second or 2 seconds depending on which part of the calculation we're doing. So s is what we're looking to find here. S equals ut plus half at squared. U here is 0, so ut is 0, and that means s equals half at squared. So after 2 seconds, s is going to be equal to 1/2 times 1.27 times t here is 2. So that's s of 2 minus s of 1 will be, the acceleration is the same, so it's half times acceleration, which is 1.27, and for s of 1 the time is 1 second, so that is s of 1, which gives you half times 1.27 times, let's factorise, so let's take out the 1.27 times a half as a common factor. So 2 squared here would be 4, and 1 squared would be 1. So if we calculate that, or we could just enter that line into the calculator, don't really need to play around with it if you don't feel the need to, and we get 1.90 metres. That's how far it travels in the second, which is not very far, and that's not surprising because it's only beginning to accelerate really, which means that it's not travelling very fast at that time. Okay, so now we're ready for part C, and something's not right and the pilots want to abort the takeoff when they hit a speed of 50 metres per second at the acceleration found in question A. So that acceleration we found to be 1.27 metres per second squared. Find the maximum deceleration they must undergo if they are to stop before the end of the runway. So the first thing we need to find is how much runway they use up getting up to a speed of 50 metres per second, because the answer to the acceleration or the deceleration that they need must depend on the amount of runway that is left over after it's reached a speed of 50 metres per second. So let's look at the accelerating up to 50 metres per second first. So accelerating, it's going to start from rest, so the initial velocity must be 0, and it's accelerating up to 50 metres per second, and we need to find the displacement that covers, so we need to find S here. So again, we're using v squared equals u squared plus 2as, and again u is 0. This time we're trying to find the value of s, so we're going to divide through by 2a. We get s equals v squared divided by 2a, and v is 50, so that's squared, divided by 2 times 1.27, and if we calculate that we get an answer of 987 metres. So it uses up 987 metres out of 2,059 metres of runway. So the amount of runway left would be 2,059 metres minus 987 metres, which gives you 1,072 metres, and the plane would need to be able to stop within that distance. Okay, so now we're looking at the plane coming to a stop. So here we're looking at the deceleration. Plane starts off the deceleration at a speed of 50 metres per second and needs to come to a stop, so it needs to be brought to a final speed of 0. We need to find the acceleration, and we know the displacement must be at a maximum 1,072 metres. So again, it's a job for v squared equals u squared plus 2as, and if we put in what we have here, we've got 0 squared equals 50 squared plus 2 times a multiplied by 1,072. So therefore, if we move the 50 squared to the other side of the equation, we get minus 50 squared equals 2 times a times 1,072. So we're going to get a, we need to divide by 2 times 1,072, and we are going to get a negative answer here. That's what we're expecting because the plane is slowing down, and therefore it's going to be a negative acceleration. The value we find to be 1.16 metres per second squared. Thanks for watching. Over and out.